Now let's calculate the uncertainty. Okay. So what we got, I mean, momentum is pretty basic, right? Momentum is just m times v. Okay. So before, let's figure this out here. So before, my mass is 300, that's just the mass of A, right? 0.0 plus or minus 0.05 grams, okay? Afterwards, it's very complex, right? It's going to be 300.0 plus or minus 0.05 plus 291.2. This is after, right? Plus or minus 0.05. So that is, I would reckon that is 591.2. And here's the the important distinction that's going to make almost no difference at all in our calculations. But remember when you add two numbers like this, the uncertainty is 0.1. Okay. Now, really, if you wanted to do careful work, what you should have done was put both gliders on the scale at once, and then the uncertainty would be half that. But since the uncertainty is so vanishingly small, it really doesn't matter. Okay. So this is our mass, right? Our velocity is 0.170, and that's plus or minus 0.0065, okay? And we arrived at a momentum of 51 and I'm saying 0.0 gram meters per second, okay? Now here, my velocity after is 0.091 plus or minus 0.0035. I'm feeling bad there's not a zero there. Okay. Okay, right? And notice that we arrived, in this case, at a momentum of 53.8 gram meters per second. So now what we're going to do is we're going to set up an uncertainty thing, right? So the uncertainty momentum is to momentum as the uncertainty of mass is to mass plus the uncertainty of velocity is to velocity, right? Okay, so let's do this. The uncertainty of momentum is to 51.0. That's the uncertainty of mass, which is, right, this term isn't going to do much, but there it is. We'd feel bad if we didn't do it, right? This will do something, though. Whoops. It's a 170. Ignore the zero that tried to be there. Okay? 0.0065 over 0.170. It's this number here. I wish I could erase. All right, but I can't. Okay, so what I'm going to do here is I'm going to take this, and I'm going to go this over this, plus this over this, and then multiply by 51, right? And that'll get rid of it there. Okay, so 51 times left parenthesis 0.05 divided by 300, which is, essentially 0, right? Plus 0.0065 divided by 0.17, right parenthesis, enter. And that's 1.9585, okay? So delta P, 1.9585. So I'm going to say that that's about 2.0, okay? That's gram meters per second, okay? So before it was 51.0, right? Plus or minus 2.0 gram meters per second. Okay, so let's figure it out afterwards. We're going to go uncertainty of the momentum over 53.8 is equal to, and then 0.1. By the way, that won't change the fractional uncertainty very much. Plus, let's see, so this is our uncertainty of the mass over the mass, plus the uncertainty of the velocity over. Okay. Are we ready for this? So again, you're going to go parentheses. Let's multiply both sides by 53.8. Okay, so 53.8 times left parenthesis 0.1 divided by 591.2 plus 0.0035 divided by 0.091, right parenthesis, enter. And that's 2.078. Okay, so I'm going to say that that's about, we want to round these to 2 digits is the general rule, 2.1 gram meters per second. So now we've got these two momentums, right? Before it was this. Afterwards, it was 53.8 plus or minus 2.1. Okay? Now the question, sorry, gram meters per second. Okay? Now the question is, could they overlap? Now clearly they could, right? Because there's only a difference of 2.8 separating before and after, right? It's 53.8 minus 51 is only 2.8, right? And the total uncertainty adds up to 4.1. So I mean that's the true test, right? But I'll show you how to make this argument in the next video. Okay.